Right, in the earlier example, in the earlier video, what I have done for this specific term formula is to actually expand all this, right, using this rule that we have learned. And that will give us right. Then I realized that some students may have difficulty dealing with when the power is involve algebra, right? When there's so many algebra to manage, uh, you may make mistakes. Also, this portion here, right? You may make mistake here. You may forgot to extract your -1 from your x term. So I think a better way, or not a better way, sorry, a neater way is just to concentrate on the x term, right? We just concentrate on the x term to get the general formula involving r, because this is what we are interested in first. So if we just concentrate on the x term, then look at what that's highlighted there, right? So we just apply this rule to have underlined in green, right? And this is what you'll get. You will have 2 times 9 gives you 18. 2 times -r gives you, so altogether it gives you 18 minus 2r, which is what I have here. And likewise for this, you just take -1. That means you temporarily ignore the negative sign here, right? You just concentrate on your x to the power -1. So -1 times r is -r, so you get x to the power -r here. Then you can apply this rule that we have learned. You just add the power because you're talking about the same base, which is x. So you just add the power and you get this general term. Right, so this one is very useful. It really, depending on what terms you want to find, x to the power of 3, x to the power of 4, x to the power of 0. X to the power of 0 is term independent of x. Anything, right, you just equate it. So in the questions, we are asked to find x to the power of 3. So you just equate it to x to the power of 3. And you'll get r equals to 5. So r equals to 5 means this term, x equals to 3, is at the 6, is the 6th term. Because when you substitute r equals to 5 here, you get t6. 6 means it's the 6th term. So when you expand, let's say the expansion is 10 terms, right? You'll be getting, no, the power n, let's say the power n is 10, you'll get 11 terms. And this x to the power of 3 is actually at the 6th term. The position is at the 6th term position, right? So if you equate it to x to the power of 6, then you get r equals to 4, means you can actually find x to the power of 6 at the 5th position. Right, so after we have managed to find where the position where it is, r equals to 4, r equals to 5. Now we can substitute into our specific term formula to find exactly the term, the exact term. So we substitute r equals to 5 into 1, right? And then you just work it out. Okay, so when you expand now, when you expand, you have to be careful with this negative. Okay, this part here, you need to be careful. This will give you -1 times x to the power -1. -1 times x to the power -1, then the whole thing to the power of 5. So here you have to be careful. Okay, you just have to watch out for that. Right, and from here onwards, you can just use the calculator. The one that I've highlighted in double lines, you can just use a calculator to evaluate the values, and you get 2016. And of course, x to the power of 8 times x to the power of negative 5 must give me x to the power of 3. So this is also one way to check if you have found your r equals the value of r correctly. So therefore, the coefficient of x cubed is negative 2016. Then you do the same when r equals to 4, and you get the coefficient of x to the power of 6 to be 4032.